Okay, you guys, welcome to Math 100. And so our first lesson in Math 100 is section 5.1, add and subtract polynomials. So first we need to decide what exactly is a polynomial. That is a single term or the sum of two or more terms containing variables with whole number exponents. And always written in descending order if we have a polynomial. So an example of a polynomial written in descending order would be 7x cubed minus 9x squared plus 13x minus 6. So this would be an example of a polynomial in descending order. So the thing that makes it descending are these exponents right here. So notice we have an x cubed and then we have an x squared. The exponent here is a 1 when you don't see the exponent, and then there is no variable in the last term. That would be considered our constant term. So this is what descending order looks like. Now, if I want to actually do what that says and simplify that polynomial, that's where we're headed. Before we get to simplifying, what we want to do is I want to think of this as 7x cubed. I'm going to change this minus to a plus just for a moment. I know that some students prefer to write theirs all as addition. I particularly do not usually do this because I don't like to see two signs directly beside each other like these two. I don't like to see a minus and a plus. A minus and a plus. I always turn those into what the original equation says. But for the sake of where we're headed, I just wanted to point this out. When you think of this second term here, it is a negative 9x squared. All right, so there's a couple of other words that we need to look at before we move on. All right, one of those words is the degree. All right, each term has a degree, and so a term looks like this, and its degree is just that n. All right, so this AXN, that would be considered a term, and its degree is n. If we're talking about the degree of the constant term, okay, now remember I said that negative 6 up there was our constant because it does not have a variable. A constant term always has a degree of 0. So if we look at our polynomial that we have sitting up here, I'm going to separate it into each term, the coefficient for each term, and the degree for each term, just so that we can see what all of those things mean. The coefficient, I said that word, so I feel like I need to make sure you understand what a coefficient is. A coefficient is the number part of the term. So in this case, the number part of our term, if I had a x to the n, there's our term. Okay, there's our term. So the number part would be the a, would be the coefficient. Just abbreviate there. All right, so the a is the coefficient there. All right, so let's take our little polynomial that I have here, and we're going to make a little table. And in our first column, we're going to identify each term of the polynomial. So our first term is 7x squared. Our second term is negative 9x squared, making sure to take the sign with it. Our third one is 13x, and then our last one is negative 6. So there's each of the terms of our polynomial. Okay, the next thing that we'll look at is the coefficient for each term. Now remember I said the coefficient is the number part of the term. So the coefficient here would be 7, negative 9, 13, And even though -6 is a constant, that is still the number part, so that -6 is our coefficient. And then we're going to look at the degree of each term. All right, so of this first term, the degree, remember I said the degree was the exponent, the n value. So in this case, our degree is 3. Here it is 2. Remember, when there is not an exponent on the variable, we understand that it is 1. And then our constant doesn't have an exponent, and so the statement I wrote above, the degree of a constant term is always 0. So this table is something that you will see in my math lab in one of your assignments. So you can revisit that if you need to. All right, our next little idea is there are 3 types of polynomials. Okay, polynomial is like a family name. For instance, my last name is Wirtz, and so all of my children have the name Wirtz. So they are all in the Wirtz family. And so polynomial is like a family, and then we get specific if we talk about, in my children's case, their first name would make them specific. So one of these would be considered a monomial, and then we have a binomial, and then we have a trinomial. Now, I have 3 children, and so this would be like having my 3 children, Allie, Gabriel, and Michael. So monomial, binomial, and trinomial are 3 different kinds of polynomials. What makes them different is a monomial is exactly one term, like 2x or 5x squared, okay, just one term. A binomial has 2 terms. A trinomial has 3 terms. Now, our polynomial at the beginning of this page that we've been going over in our notes is none of those, because our polynomial that we've been working with so far has 4 terms. So when it has 4 terms, it no longer gets a particular name. You just call it a polynomial. If it has 5 terms, you call it a polynomial. So it's kind of like if I had one more kid, I wouldn't give them a name. They would just be words, which is silly, but that's kind of how we do it in math. All right. All right, and so we talked about the degree of a term. Now let's talk about the degree of the entire polynomial. Not just the degree of each term, the degree of the polynomial. And so that would be the greatest degree of all the terms. So if we look back up at our table that we completed just a moment ago, so I'm going to scroll back so we can see that table. Right, so if we look at the degrees that we have listed here, obviously 3 is our highest degree, that's our greatest degree. So if I wanted to know the degree of the polynomial, it would be the highest of the ones that I have listed here. So in this case, it would be 3. The degree of this particular polynomial is 3, the highest of the degrees of each term. All right, so we've kind of laid some groundwork with some vocabulary, and so now let's actually get to adding and subtracting. All right, so when we add our polynomials or when we subtract them, we need to make sure that we have like terms. All right, so we can only add and subtract like terms. And so in order for things to be considered like terms, they have to have exactly the same variables. All right, the other thing that they have to have is that those variables have to be raised to the same powers. All right, so let's look at a couple of these to see what like terms would look like. All right, so I'm just going to make a little list here. Things that might be like terms would be 3x squared and negative 2x squared. Those would be considered like terms. They have exactly the same variable raised to the same power. If I had something like 12xy squared and I had 3xy squared, those would be considered like terms that have exactly the same variables raised to exactly the same powers. All right? So things that are not like terms, just to give you an example of that, all right? If I had 3x squared and 3x, those are not like terms. The 3 has nothing to do with them being like terms, has everything to do with the variable and the exponent on it. They both do have an x, but the first one is x squared and the next one just has an x to the first power. So these are not like terms. So let's actually take a problem where we have some like terms we're going to have to identify, and then we will add and subtract if we need to. All right, so let's start with negative 9x cubed plus 7x squared minus 5x plus 3. We're going to take that polynomial and we're going to add this second polynomial to it. So 13x squared plus 2x squared minus 8x minus 6. I'm sorry, 13x cubed. All right, so we are going to add these polynomials. Now, the first thing I'm going to do is identify what my like terms are. Now, I'm just going to use a different color to underline so we can decide what are the like terms. All right, so here we have an x cubed and an x cubed. So those would be considered like terms. We have here an x squared and an x squared. So those would be considered like terms. This negative 5x and this negative 8x would be considered like terms. And then our last one, this 3 and this negative 6, neither one of those has a variable at all, so they would be considered like terms. So when I get ready to do my adding of terms, we can only add the like terms. All right? So I'm going to show you two different ways. My math lab is the first way that I'll show you, because my math lab, what it does is it's going to take this first polynomial and it's going to put the other polynomial up under it, making sure to line up our like terms. Notice that my like terms are lined up on top of each other. And then I'll come over here and put a plus. All right, so now I'm actually going to do it. So I add the coefficients, the numbers in front. So negative 9 plus 13 would give me 4x cubed. Positive 7x squared plus 2x squared would give me plus 9x squared. Negative 5x plus negative 8x. When the signs are the same, we add and keep their sign. So that's something that hopefully if you took Math 98, you're clear on. Some of you may need a little help with your integers. Let me know if you need some extra help there. And then our last two would be 3 plus negative 6. My signs are not the same this time, so I subtract and take the sign of the larger one. So this would be my solution right here. There are no like terms in my answer, so we leave the answers just like that. Now, my math lab calls this vertically. It just says to work the problem vertically. That is your option if you want to stack it on top of each other like that. Some people don't like to stack it vertically, and that's okay if you don't want to write it vertically. What I do want is to see your work. Okay, so the other way to do that, all right, this way is stacking it vertically. All right, if I choose not to write it vertically, then I'm going to put like terms beside each other. So let me slide this up just a bit. All right, so if I'm not doing it vertically, then I would write my like terms beside each other from the original problem. So those two I underlined in green, they are like terms. Then I have plus 7x squared plus 2x squared. Those are like terms. Minus 5x plus, now notice here, I have a plus negative 8x. I have to be careful with my signs. And then my last two terms are a plus 3 plus negative 6. All right, so now I'm ready to combine my like terms. These first two are like terms, so I get 4x cubed. You add their coefficients. Signs are not the same, so we subtract. Take the sign of the larger one. Okay, now I would add these two like terms. I get 9x. Okay, these two like terms, my signs are the same, so I get negative 13x. And then over here, my last two, the signs are not the same, so I subtract and keep the sign of the larger one. So notice our answer here is exactly the same as we got when we wrote it vertically, except I have a small error on my board. Here we go. That should have had a 9x squared. The variable does not change, nor does it exponent when you are adding and subtracting. So notice that the two things that I circled in red are exactly the same thing, no matter which way you write it, vertically or if you write it beside each other. Doesn't matter to me. All right, so one last little idea that I want to show you is if we are subtracting, sometimes that's where it gets a little crazy. And so in my math lab, they're going to give you some problems that look something like this. They're going to say subtract. And then they will list for you a polynomial. And they will say subtract it from, and then they'll list another polynomial. All right, so there's our two polynomials. All right, so if I choose to write it vertically like my math lab likes you to do, then here's what I have to decide. My two polynomials, here they are. There's my first polynomial. It does include that 6 right there. Sorry, my 5 kind of went away. All right, and then here is my second polynomial. All right, now, since it says subtract this first polynomial from the other one, then I have to start with the 10x cubed polynomial. Okay, that one must go on top. Okay, because of this word from, then it has to go on top because of the word from. Okay, and so then it does say subtract. And when I put this other one down here, I'm going to put a big parentheses in front because I am subtracting, which is going to matter a little bit. All right. Now, for most of us, actually for all of us, because I do want us all to show our work, that is something that I'm going to require. Excuse me. All right. So our next step is this little negative that's sitting out here. We need to do the distributive property, which means we distribute the negative through the parentheses. So over here to the right, I am going to rewrite the problem. Okay, our top polynomial is not going to change. It's going to stay exactly the same. Our bottom polynomial, now it changes to negative 3x cubed minus 8x squared times that negative out front makes it a positive. Okay, and then we had this minus 5x, but times the negative out front makes that a positive. And then our 6 is a positive, but when I multiply it by the negative out front, it becomes a negative. Now I'm ready to do what it says vertically. So I have 10x cubed minus 7x cubed, minus 3x cubed gives me 7x cubed. Negative 5x squared plus 8x squared gives me positive 3x squared. 7x plus 5x will give me plus 12x. And then negative 2 minus 6 will give me negative 8. So my solution here is 7x cubed plus 3x squared plus 12x minus 8. You will see problems like this in my math lab, so please be very careful and make sure that you write them correctly. The second polynomial does need to go on top. You're welcome to watch other videos. There are some more videos in your My Math Lab that are provided for you, but I would like for you to also watch all of the videos that I provide on our YouTube channel. So let me know if you have any questions. I look forward to seeing you in our Teams meeting.